we will discuss Coulomb's law. Let us consider two surfaces, Q1 and Q2. Q1 and Q2. Okay. You can consider two positive. If you consider two positive surfaces, there will be repulsion. If you consider two negative surfaces, there will be also repulsion. If you consider one positive and another negative, then there will be attraction. That means there is always repulsion between like surfaces and there is always attraction between unlike surfaces. Okay? So for this, we have considered two positive surfaces. Q1 and Q2 are the two positive surfaces and they are separated by a distance r. The two surfaces are separated by a distance r. Okay? So there will be repulsion. Okay? And that repulsive force or attractive force is also known as the Coulombic force. So according to Coulomb's law, the Coulombic force F is directly proportional to the product of the magnitude of the surface. So remember, the Coulombic force between the two surfaces is directly proportional to the product of the magnitude of the surfaces, and the Coulombic force is inversely proportional to the square of the distance between them. Okay. Combining these two terms, we can write it like this: F is directly proportional to Q1 Q2 divided by R square, or F would be equal to your K Q1 Q2 by R square. Okay. This proportionality constant is also known as electrostatic force constant. K is electrostatic force constant. Electrostatic force constant. And the value of K depends upon the nature of the medium between the two surfaces and the system of units we use. Okay? You remember, the value of K depends upon the nature of the medium between the two surfaces and the system of units. Okay? If we choose free space, between the two surfaces, okay, we have considered free space between the two surfaces, and we choose SI system, then the value of K will be equal to your 1 by 4 pi epsilon naught. Okay? 1 by 4 pi is okay. But what is this term? This is epsilon naught. This is epsilon naught. This term is known as permittivity. Permittivity of the free space or vector. Epsilon naught is known as permittivity of free space. Okay? And the value of K is equal to 9 into 10 to the power 9 Newton meter square per Coulomb square. Newton meter square per Coulomb square. Okay. Therefore, the Coulomb's law becomes F is equal to 1 by 4 pi epsilon naught. In place of K, what we can write? We can write 1 by 4 pi epsilon naught Q1 Q2 divided by R square. So this is the Coulomb's law in SI system. Okay, remember, this is the Coulomb's law in SI system. Coulomb's law in SI system, which is equal to 1 by 4 pi epsilon naught Q1 modulus of Q1 Q2 divided by R square. Okay, what is this term epsilon? Epsilon naught. This is the permittivity of the free space. Okay, so this is our Coulomb's law. And the numerical value of this epsilon naught is how much? It is 8.85 into 10 to the power minus 12 Coulomb square per Newton per meter square. The numerical value of epsilon is 8.85 into 10 to the power minus 12 Coulomb square per Newton per meter square. So this is the value of permittivity for free space. For different medium, the value of this permittivity will be different. The value of this permittivity will be different. That means the medium between the two surfaces plays an important role for the force, for the electrostatic force. Okay. In question, one question frequently comes. That question is, what is the dimension of epsilon naught? Dimension of epsilon naught. Okay. Question is, find dimension of epsilon naught. What is the dimension of epsilon? Okay, this question will come for 1 mark. For this, write the Coulomb's law. F is equal to what? 1 by 4 pi epsilon naught Q1 Q2 by R square. Just now writing the magnitude. Okay, so we need to find the dimension of epsilon naught. So epsilon naught will be equal to 1 by 4 pi. It is constant. Q1 Q2 divided by F into R square. So epsilon naught will be equal to Q1 Q2 divided by F R square. And dimension of epsilon naught will be equal to 1 by 4 pi is constant. This dimension, it has no dimension. So dimension of Q1 and Q2 both are the surfaces. Dimension of Q is what? A into T. We have already discussed in my last classes. So there are two surfaces. That is what? Dimension will be A square T square. What is the dimension of force? Dimension of force is equal to your ML T to the power minus 2. ML T to the power minus 2. We have discussed in first year. Dimension of force. And dimension of R is what? R is the distance. So dimension of R is your L square. So it will be your A square T square divided by M L to the power 3 T to the power minus 2. Finally it will be your M inverse L to the power minus 3 T to the power 4 A to the power 2. So this is the dimension of epsilon. And this is our Coulomb's law in SI system. So remember, force is a vector quantity. But in this equation, we have shown only the magnitude. This is what? This is only the magnitude of the force. Okay? What is the direction? For direction, we need to explain in Coulomb's law in vector form. Okay? Now, I am going to explain Coulomb's law in vector form. Coulomb's law in vector form. Okay, Coulomb's law in vector form. For this, consider two positive surfaces. Okay, this is Coulomb's law in vector form for light surfaces. For light surfaces, that means I consider two positive or two negative. Okay, Coulomb's law in vector form for light surfaces. That means Q1 and Q2, these are the two positive surfaces separated by a distance r. Okay, separated by a distance r. So both surfaces are positive. Okay, remember the Coulomb's law is only valid for point surfaces. That is why these are Q1 and Q2. These are the point surfaces. Okay, these are the point surfaces separated by a distance r. So both are positive. This Q1 will exert a force Q. Your Q1 will exert a force Q2, or you can say that Q1 will repel Q2 in this direction. Okay, this is both are positive. That is what Q1 will repel Q2 in this direction with a force F21. What is this F21? F21 means force on surface Q2 due to Q1. What is this F21? F21 means force on surface Q2 due to Q1. That means Q1 is repelling Q2 in this direction. Here Q1 is exerting that force. Okay? And if you write in vector form, your F21 will be your 1 by 4 pi epsilon naught Q1 Q2 by R square. This is what? This is the magnitude. Okay? So the direction of the force is, we can write in the direction from Q1 to Q2. Okay? This is what the magnitude of the force, and direction of the force is from Q1 to Q2, in the direction from Q1 to Q2. Okay? Or we can write like this also. 1 by 4 pi epsilon naught Q1 Q2 R square. The direction from Q1 to Q2 is also represented by the unit vector R12 cap. The direction of the forces from Q1 to Q2 is also represented by a unit vector. What is this R12 cap? R12 cap is a unit vector in the direction from Q1 to Q2. Okay? So here R12 cap is a unit vector in the direction from Q1 to Q2. So this is the vector form. Okay? Here Q1 will repel Q2 in this direction with a force F21. What is this F21? Remember, F21 means force on surface Q2 due to Q1. And this is the magnitude of the force. 1 by 4 pi epsilon naught Q1 Q2 by R square. This is the magnitude of the force. And this is what? This is the direction. In which direction? Q1 is repelling Q2. In the direction Q1 to Q2. Okay? And that direction is also represented by R12 cap. What is this R12 cap? R12 cap is a unit vector pointing from Q1 to Q2. Okay? Similarly, Q2 is also repelling Q1 in this direction. Q2 is also repelling Q1 in this direction with a force F12. Okay? So what is F12? F12 means force on surface Q1 due to Q2. Here Q2 is also repelling Q1 in this direction because both are positive. The force will be mutual. Here F12 is what? Force on surface Q1 due to Q2. Okay? It will be equal to, the magnitude of the force is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R square. And the direction of the force is from Q2 to Q1. You can write in the direction Q2 to Q1. So this is what? This is the magnitude of the force, and this is the direction in which the surface Q1 is repelling. Okay? We can write it also. F12 is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square to your R21 cap. That means the direction Q2 to Q1 is also expressed by R21 cap. R21 cap. This is the position. R21. So R21 cap is what? It is a unit vector in the direction from Q2 to Q1. Okay? This is the Coulomb's law in vector form for like surfaces. For like surfaces where there is a repulsion between two surfaces. Okay? For unlike surfaces, the equation will be different. Okay? Now see, for unlike surfaces. For unlike surfaces, what happens? Unlike surface, suppose Q1 is positive and Q2 is negative. They are separated by a distance r. Here Q1 and Q2 both are point sources. Q1 is positive and Q2 is negative. Okay, so here Q1 will attract Q2 in this direction with a force F21. Okay, because Q1 is positive and Q2 is negative, that is why the plus Q1 will attract minus Q2 in this direction. Okay, what is this F21? F21 means force of attraction. Force of attraction on surge Q2 due to Q1. Okay, what is this F21? Force of attraction on surge Q2 due to Q1. The Q1 will exert that force. Okay, and Q2 will feel that force. Q2 will feel that force. Okay, if you write in vector form, okay, so it will be, if you write an equation, it will be, or the magnitude of that force will be 1 by 4 pi epsilon naught Q1 Q2 by r square. Okay, and the direction of the force is Q2 to Q1, and the position vectors is LOS from the origin who create that force. Okay, the position vector is LOS originate from that source where the source is originated. That means R1 to K. Okay, so with your R1 to K, and you can see the direction of the force F21 and the position vector R1 to K are opposite. Okay, the direction of the force F21 and R1 to K are opposite. That is why a negative sign will appear before this equation. Okay, this negative sign is not because of the surge. This negative sign is because of the opposite directions. The direction of position vector is from Q1 to Q2, and direction of attracting force is from Q2 to Q1. That is why their direction are opposite. That is why this negative sign will appear. Okay, so the position. So I will again repeat this. Suppose I have considered one positive, another negative. So this plus Q1 will attract minus Q2 in this direction with a force F21. F21 is the force on surge Q2 due to Q1. Here Q1 will exert that force. Q1 will exert that force. ये force किसने exert किया? Q1 ने exert किया. Force किसके ऊपर लगा हुआ है? Q2 के ऊपर लगा हुआ है. तो force का origin किसमें है? The origin of the force is Q1. That is why the position vector will come from Q1. Is a position vector R21 क्या है? It will comes from Q1, and the direction of position vector is from Q1 to Q2, and the direction of force is from Q2 to Q1. So you can see the directions are opposite. That is why this negative sign will appear. So F21 का जो direction है, that is from Q2 to Q1, and R12 का जो direction है, that is from Q1 to Q2. The directions are opposite. That is why this negative sign will appear. Okay, you remember this negative sign is not because of this minus Q2. It is because of the opposite direction of these two vectors. Okay, similarly, this minus Q2 will also attract Q1 in this direction with a force F1. Minus Q2 will also exert a force F12 on surface Q1. This is also a force of attraction. This time the minus Q2 will exert that force. That is why the position vector will come from minus Q2. That means R21. Here also the direction of F12 and R21 cap are opposite. That is why we can write F12 will be equal to 1 by 4 pi epsilon naught Q1 Q2 by R square R21 cap. So you can see the direction of F12 and the position vector R21 cap both are opposite. That is why this negative sign will appear. Okay, so when the force is attractive, Okay, the value will be negative. That means the negative force means there will be attraction, or positive force means there will be repulsion. So this is the Coulomb's law for in vector form for unlike surges. Okay, in next class we will discuss the dielectric constant or relative permittivity.